let's use bond enthalpies to estimate delta H for this reaction. Now, it's very difficult to do this experimentally. This reaction is a key reaction inside of a flame. It is one of the key reactions that converts carbon monoxide into carbon dioxide. And notice that it involves a couple of free radicals. The OH radical, this has an odd number of electrons, and the H radical, which also has an odd number of electrons. If we write down the Lewis structures for these things, we've done the Lewis structures for all of these things before, so I'll just write them down really quick. We'll see what kind of bonds we have. So when you're trying to predict what delta H is for a reaction using bond enthalpies, you have to know what bonds you've got. So you have to write the Lewis structures for everything down. Now let's see what's happening in this reaction. This bond and this bond are being broken. That's going to cost us energy. We're going to add the bond enthalpies for those two bonds in as positive numbers. Let's look at that table that we've got in the worksheet of bond enthalpies. And it's got a C triple bond O as, what do I see, 1070. So that's the bond enthalpy for breaking that. And what's the bond enthalpy for breaking an OH bond? Well, that one's not in the table, but I can go look it up, and it's 464 kilojoules for an O single bond H. So these are the two bonds that are broken in the reaction. What are the bonds that are formed? Now I'm going to put a minus sign in front of each of the bond enthalpies. I've got C triple bond, or C double bond O and C double bond O. So I have two C double bond O's. I'm going to say 2 times, let me see, C double bond O is in my table. It's 745. And notice I'm putting a minus sign in front of that because this is a bond being formed. And now what else have I got? Well, that doesn't have any bonds in it, so I don't have to do anything with that. Now to get delta H, I need to add all this stuff up together. 1070 plus 464 plus 2 times minus 745 is going to give us what? $44. It's got a positive sign in it. So what does this tell us? It tells us that this is going to require energy. 44 kilojoules of heat has to be supplied to get this reaction to go. What we're doing is we're breaking some stronger bonds and making some weaker bonds. And in that case, we got a net absorption of energy. So we would say this was, what kind of reaction is this? Is it exothermic or endothermic? Because this is positive, it's endothermic. It's going to absorb energy. You've got one something like this on your handout, on your worksheet.